All right. So, like I said, tonight I want to go over our 3D printing options, which is generally the printers we have, and what printers we're going to be using for this project. We're also going to discuss just a quick brief history of just general 3D printing, and introduce you to the printers we do in fact have. So to get started with that, let me share my screen and all of that fun. Transfer over. All right. So first off is the printers we have. We have two types of printers here, an FDM and an SLA printer. This is all available on Blackboard. But the ones we have are FDM, or as it says here, fused deposition modeling. There we go. I always forget those. Basically, those are the filament ones. Those are the extruder ones. Those take the spool of material and extrude it out onto the print bed like a hot glue gun and building up layers and layers. The other option is the SLA. I always forget, stereolithography apparatus. Ooh, apparatus. Basically, same deal, only instead it uses light sensitive or UV sensitive resin and uses a UV laser to harden layers of resin in each layer. The difference there, the basic difference being the filament is cheaper, but it can't get as detailed, but it does have larger build volumes. The resin can get much, much more detailed, but it has a much more limited build volume. Material is more expensive, and it tends to be a little bit slower because it prints solid. Whereas the filament ones, you can adjust how hollow it prints. Basically, it prints the shell, and you can print some kind of webbing in between. Think of that as like bird bones. You ever seen a bird bone, the cross section where you have a shell and it has all the little webbing in between? That's basically how a filament extruder 3D printer prints. Whereas resin, it prints through and through solid. So the basic examples, the ones we have modeled here is from a company called Prusa, or I think it's also pronounced, or no, actually pronounced Prusa. Yeah, I've yet to actually get a definition on that. Anyway, what it does is it takes a variety of different types of filaments, and we have a variety of those. Some are more applicable to different applications. Some are dependent on just what color you want. And we do have a range of that. Basically, what it does is it takes that filament, extrudes, and gets it to stick together by partially melting it and pushing it out of a nozzle. So you are limited by the detail by how big that nozzle is. All three of the filament printers we have a 0.04 millimeter nozzle. No, sorry, a 0.4 millimeter nozzle. That'd be freaking tiny. So it's really little, but depending on how small your stuff gets, it can be limited. But these work very reliably, and I'm quite pleased with them. Big thing also, if you're interested in looking into your own printers and such down the line or anything, filament printers, FDM printers tend to be much cheaper themselves, but they also depend. But that also varies quite wildly. The SLA printer. Like I said, this prints layers of resin. Instead of extruding a material, it has a bath of this light-sensitive resin. So think of like you ever used like 2 or 5 minute epoxy, things like that. Squeeze the two tubes and mix them together and such. That's essentially the same thing, only instead of a chemical hardener and a resin, this uses a UV laser, and the resin itself, like I said, is light sensitive. So when you're done with that, one of the things is it's not fully cured once the part is printed. You usually have to clean off the excess resin with some sort of light solvent like isopropyl alcohol, or you can go up to something as aggressive as acetylene, acetone, which is kind of sick, but that can also eat your print. So you want to do that quickly, not like it's only going to take a couple of minutes to eat it, but you don't want to leave it soaking overnight. I learned that. And again, like this uses a laser. There's of course differences as well, like orientation and all that such. Not really important. And this uses ours. We have Formlab printers, and they use proprietary resin, whereas the filament printers can be, the material can be sourced from a great number of different locations and makers. Some are cheaper, and probably because of that, they're not as good, or vice versa. Others, pretty well good. Difference being just ballpark. A roll of filament, as you can see the ones hanging there, they run about $20 a roll, and that's about 5 kilograms of material, which ends up being a lot of material. The resin printers, you see the little bottles next to them. That's about a half a liter of resin, and that runs about $100 for a bottle of resin. So if you're interested, that's the price breakdown. This also includes a variety of explanation of the different materials themselves. We will be using, we have access to basically PLA and PETG. We also have ABS material. We're going to go over exactly what that means. And those are the general ones we have. I will tell you now, the Prusa printers can print any of them. The MakerBot can only print PLA. That is the lowest melting of them, and that is the only one it will print. They will both print from the same type of spool. They both can print PLA, but this one cannot print any of the other materials. So just so you know, if you want to use either of them. And this has a breakdown quickly of the other stuff. And we'll, as far as the resin, we'll have the one type of resin. You can get other types of resins, but because of how we operate in this course, we're just going to be using the general stuff. Quick breakdown, that sort of stuff. You can see the different ones. Like I said, the resolution is dependent on the size of the nozzle. The SLA is the size of the laser beam, so significantly more detailed. There are issues, and we'll go on through the semester discussing things like with the filament ones of different layer bonding, things like that. Basically, it means how well does each layer stick together. Because the breakdown of any of these is, what does a standard computer printer do besides break when you really need it? It prints one image on one piece of paper. Think of how these build your 3D models as taking your model, and the reason the preparing programs, which we're going to talk about in a moment, are called slicers, because that's exactly what they do. They take your 3D model and slice it into a stack of little sections of your model. So basically, in essence, a 3D printer is a standard printer that prints a stack of papers that you can put together, that you could put up, or put a stack on top of each other. Only obviously different. There's a couple of differences. But anyhow, that is in essence what happens. How it translates your 3D model. The slicer program literally does that, slices it into a whole bunch of layers, dependent on the thickness of the material and nozzle, or the accuracy of the laser. That's how many layers it breaks it up into, and stacks them. And what I mean by it bonding together is filament. The filament printer, as I said, it melts, or partially melts. So as it melts, it kind of glues down. As it cools, bonds together, hopefully well, and keeps stacking higher and higher. Laser printer, yeah, it pretty much does exactly what it sounds like. The difference being is it is hardening layers of resin, and then it moves up, shoots another laser shoots another layer of it, raises up, shoots another layer, shoots another layer. Pretty much how it works. Painfully simplified, but also in essence, that's pretty much it. There's a fair amount of things on here, like removal. We will go over exactly how. The filament printers print all onto a bed. Our two Prusas, actually the bed is magnetic. You can lift that layer up once it's cooled, because it will get hot, very, very hot, as in the stuff has a melting temperature of, like, the hotbed, the nozzle itself gets up to, depending on what material, anywhere between I think it's 215 to let's say 260 centigrade, so it's rather warm. And then the heat bed is usually somewhere between 90 and 150 degrees centigrade. So well above boiling and very much burning temperatures. Resin printer just kind of warms the resin up, so it's not like trying to shoot into cold resin. It doesn't cure as quickly. Oh, that's what. But the sheets are magnetic. You can flex it. Model pops right off. Really convenient. The resin printer, you actually have to chisel it off of the bed. A little more problematic, but they do actually sell now flexible beds for those. Irrelevant information, but just stuff to know of. As I already discussed, printing costs. Spools are pretty cheap, except for there are, of course, specialty materials. Resin is much more expensive, but you get way more detail out of it. So totally up to you. Which one should you use? Well, we're going to start the semester learning the FDM, the 3D, extrusion printers, and we'll move on to the SLA as we get further into the semester with appropriate projects that are much more detailed. For structural detail, as far as like what we're doing here by dimensions and such, filament printers do a very good job. They're not absolutely precise, but what I mean by that is if you're talking about in machinist terms, so within 100,000ths of an inch and such, or millimeter for that matter, yeah, there's a little bit of squish that gets a little distorted, but for the most part, pretty spot on. As it says here, basically, when do you use these? FDM, when you're doing rapid prototyping, trying to do like low cost builds or just test pieces. Some of the materials and what we're doing and what we already have, yeah, are pretty well good to be used. So we will be printing things like and testing pieces like with this badge. If you made it into like a keychain, something like that, yeah, it's totally usable. Is it a little delicate? Yeah, a little delicate. We're going to talk about ways to how you can actually shore it up and such, make it stronger, depending on both on the filament as well as how it gets printed. These can be printed, or sorry, these can be sanded and painted and such. So the base material that or the color that it is not the end all. We're going to talk about how that, when to use SLA, when you need super fine detail. So when you see things like people painting or people making like tabletop game miniatures and stuff like that, oh yeah, that is totally a time to use an SLA printer. When you have high texture builds and things like that. We are not going to be addressing that this semester because this is much more of a survey course, but that can be taken to that level, and an SLA printer will absolutely handle that. Strength and durability model is not crucial because a lot of the resins, the basic regular resins like we have, are not structural resins, but they do make much harder resins that actually can be used pretty well up to some pretty significant applications. And that sort. Let's see here. Another thing I do want to discuss, this is an option. If you, after this class, meaning after this semester, or if you really want to get into printing but don't want to invest in your own printer, not telling you to do that, just saying it is an option. But there are a multitude of online 3D printing services that you can just, I was going to say ship your model to, but it's also called email or upload them, and they can print them for you at your specifications and send back to you. That is especially useful if you want to experiment with different materials. Many companies will print samples for you if you want to experience what those materials actually are. If you're wanting to actually test those for destruction tests or whatever have you like that, or just because you want to. So that's a quick readout of what those are. One of the things we're going to talk about in a moment is also how do you get these material, or how do you get these your model ready for printing. All right, so with that, let's talk about exactly that. So you've got your model. Let's switch back over there. I'll open up my example, the old Bender badge. All right, bite me, meat bag. Good stuff. And as I said, it is currently displaying. And let me transfer my screen share. No, that's fine for where it is. Pardon me a moment. I just want to make certain that there's in fact, yep, that's what I was afraid of. Let me transfer back over to general screen. There we are. Want to bring up, so we'll be flip-flopping back and forth. Okay. I've got my object. It's done. We're going to say that I like it. I can always make changes. All right. How do you go to print this? Now, technically, Fusion 360 can go directly to a printer, depending on the printer. Fusion 360 is part of the Thingiverse MakerBot community and such. And so this actually could go directly to a MakerBot printer. But to show you the more universal type, be that if you're using ours, you have access to your own, anything like that. How do you do that? Well, first thing, make sure you have selected the thing you actually want to print. Because you have multiple parts, multiple components, things like that. Maybe you want to print them off in separate components. As we get to more complex things, you will want to do that. So what you do is just select either the whole component, if it's one solid component, or open the drop down, bring up that one body, which is one and the same with this, and select that. So I've got the whole thing selected. Now go up to File, and you're going to directly 3D print. It opens up a toolbox. Now down at the bottom here, it does have an option, send to, or an output, send to 3D print utility. 3D print, you have a few options. We have Cura, Preform. So those can work directly to some things. Preform is actually the Formlabs SLA printers, but we're going to get to that. What I want to do is I'm going to actually uncheck this checkbox, and this will now kick it out as my chosen file format. We're going to talk about those in a moment. But this will take it out to this will take it out just to a file that will be saved locally onto your computer. You will then upload that, or sorry, not upload, you will then drop that into a slicer program. I'll talk about what that means. File format. Now you have multiple options. Anybody is familiar at all with 3D printing or may have heard the terms. The standards are STL, as I said, stereolithogram, or an object file. It is an object file, OBJ. For what we are doing, it is largely irrelevant which one you use. The difference is, and I have a write-up up here, the difference is, why would you choose an STL or an OBJ file? Well, what's a 3D format file, or what's a 3D file? Yeah, it's a file that is saving a 3D object that you have modeled and such. An STL, basically the difference between an STL, STL is essentially the original printer format. These were developed in the 80s. Yeah, it is actually that old. Which is one of the reasons why there are new update versions. But an STL is sometimes an oversimplified format, meaning it cannot hold all that much information. Things like if you have a textured surface, if you get into stuff like actually modeling much more like sculpted forms in some of the other free programs like Blender or Maya, which is actually one of the other Autodesk things, or programs, you can download that with your student account. But if you get into the more detailed things like that, STLs do not save any of that information. It is very literal. If there are data points, that's what it will translate. That's all. It doesn't necessarily even save dimensions, which is why I tell y'all it is really best to operate in with Fusion and really with any other CAD program. I would keep it in metric units. These all operate on metric. Often enough, if you save, or if you're working in like fractional or something, in inches, there will usually be a scaling issue when you translate it. At least that's what I have found. Difference, otherwise, would be an object file. Object file is a little more complex. It does save things like scale and actual dimensional information. Other than that, kind of the same thing. However, there is a new file format that has been recently unveiled. Yeah. This is, go away. There we are. And this will, I realize this is not on Blackboard yet. I'll post this. This is discussing the new 3MF format. That is, excuse me. It has been developed as a standard across the board format from multiple different manufacturers and such. This will translate directly to Prusa, to Formlabs, to MakerBot, as well as other programs like, or actually other programs like Rhino, like SolidWorks, like Blender, like Fusion, all kinds of different stuff. You get the idea. It does also save things like texture maps and such. So as it shows on here, the cute little bunny rabbit in Fusion 360, as you might recognize that workspace, is just base thing. Which we'll be working with is showing appearances and such. It looks like it's on a wooden block. It will save that kind of information, which is largely irrelevant for what we're doing also. And again, we can get into the other stuff. But it will also save texture maps, orientations. It's much more detailed when it comes to like mesh formats, which is something that if you are working much more sculpturally, it will be saved, or you are working more of like with what's called meshes, working with polygons and triangles rather than like just straight angular things. We'll get into it. But that's really the main difference. You can use any of them, feel free to, but I would recommend as a standard, either just stick with an STL, because for the complexity of that we were working at, they're not going to be overly complex. Stick with STL, or if you like OBJ, they both will translate, and the new format 3MF will translate as well. So if you want to start using as default 3MF, more power to you. Know that a lot of programs are starting to move away from even having the option of an STL format. Not that it won't still work for quite some time, but that's the quick rundown of why would you choose one over the other, whatever. So just to keep with the new stuff, I'm going to save as a 3MF. Okay, we'll go to the desktop. Make sure that I have actually given that a proper name, BenderCoin, or rather, Collins_BenderCoin. Saving as a 3MF. Save. Okay. Now, I'm going to open a slicer program. What we're going to start with, and I'll show you how to get this in a few, I'm going to use Prusa Slicer. There is a universal one called Cura. I'll show you all that in a few, but I have found that there are better options and more straightforward options with Prusa. That's all. Okay, so this is the general interface. This is, if you look over at the actual printers, this is a direct replica of the print bed itself. So you will see as I import files and such, you can see exactly how large that will look on the print bed, and you can size it and orient it as you please. So you can either drag and drop or just open a new project. I'll go to there, desktop, BenderCoin. Opens up, boop, smack in the middle, flat down, that sort. If for some reason you have built your object not on the XY axis, but say on the ZY or ZX axis, what will happen is that means that this would have been, let's see here, let's rotate it. Oops, not that. Let's just say it was oriented however. Okay. I accidentally built it on a different axis. There we go. You want this to print flat. We're going to discuss when we discuss SLA printers. We'll discuss how you want to orient and things like that. But for this one, you want this to be flat. Well, how do I flatten this? I can rotate it. All right, what if I get that wrong or something? Well, it's going to try to print ever so slightly askew. Prusa has a really excellent option on here. Select the object. As you can see, all my options are suddenly not available. Select the object, now they are. Instead of trying to rotate something by hand, if you have a major face, you want to orient that to the print bed, to the bottom. I'm going to select, this next one is place on face. Very easy. Select there, and you'll see suddenly all of these highlighted areas. I could select one of these, say like on the edge, and it's going to snap. There we go. It's going to snap to that. Obviously, that's a really ineffective way of printing, but that's how that can operate. Tool is still active. Change your mind. I'm going to select the overall back of the object. Snaps it in place right there. Very convenient. Press escape. There you go. You have a variety of options, of course. You have a move option here, just like in Fusion. Select that. You can drag it around. Same axis colors. X-axis, left, right for red, green. Y-axis, front and back. Z-axis, blue, up and down. Same deal, but like I said, that's where you want this. If I was printing multiples on the same bed, I would want to move this around, and I can just cut and paste. Now there's two. You have at the top option here, you have some different scales, or add and subtract, which would have been the exact same thing. Obviously a garbage one. This button, arrange, press A, and it will auto arrange them for you in the best orientation that it thinks it should be. It's not always going to be correct. I just want one, so let's delete one of Bender's, reorient. There we are. Got a variety of different options, cut and paste and all that kind of stuff, scale, stack, cool stuff. All right, so the tools over on the right side. The top one is your quality. Just like if you're printing a paper or something, you would have the photo option, so absolute best quality possible. Takes a lot more ink, goes a lot slower. Same thing here. If I go with high detail, actually anything below, I have found anything below, well, you can use the 0.15, super detail. So you have quality or speed options. It doesn't really make a lot of difference. Normally, I use the quality 0.2 millimeter. That's right in the middle. It's not super detailed, but neither is it draft. So just like if you're printing on paper, it's not going to poop it out as fast as possible, but it usually ends up using a little bit too little ink, and it's hard to read. Kind of same here. It uses a faster and wider span of between layers, so it looks a lot rougher. For the most part, I usually use 0.2 millimeter quality. If you are wanting to test something, just make a more rough object, yeah, use draft. It works well. Select your material. We will talk about these. We have PLA, which is polylactic acid. That is the general cheap, fast, but good quality material. Issue being, it's not actually all that strong. Neither of these are all that truly strong, but relative scale. The other option we have is PETG. I forget what PET means, but it prints a little bit hotter, therefore it bonds a little bit better, it's a little bit stronger, and we have more colors in it. If you look over here, the silver one, and it says it on the side of the spool, silver one is PLA, on the right, the black and the orange, those are PET. I have other colors of both. There we are. The other option is ABS. This is the older option, in that ABS is a standard industry plastic. It melts a lot hotter temperature, which means it bonds much stronger. Problem with it is very, very finicky. We have some. We have actually quite a lot by accident, but it is very finicky and it is prone to warping. I do not recommend it. But if you want to play with it, you're welcome to it. I like to use PET. The nice standard material, works well. All right, so I've selected my material. The printer. These are both the exact same model. These are the Prusa i3 Mark III's, yada, yada, yada. That's the one. That's the default one. There you go. So that's what I want. Down here on the bottom, you have other options. We will discuss supports when we get more complex forms that are up off the build plate. You are building basically flat objects for right now. Supports are scaffolding. Like around, you see a building being worked on, all the beams and everything on the outside that are holding up, in that case, the workers and often enough material, that's scaffolding. 3D printing does the same thing because you are building layers on top of things. The next option is infill. When I discussed that filament printers print akin to like that basically print hollow with webbing inside, like bird bones, this is the density of the infill, of that webbing inside. So if you select 0, it is hollow. For this object, not a good option because it can't span across that, because basically a filament printer prints a shell. So in this case, that would be a really bad option. You need something in between there. For the most part, I would leave it at like 10, 15%, 20, maybe 20. That's a good density. There are other options. We'll discuss that later. Right now, I just wanted to get you introduced to the basics. There we go. Okay. So now I would press down at the bottom here, slice now. I've got my settings. Now I'm going to slice it. What that's going to do is literally slice it into layers. Now, the nice thing on Prusa it gives you a color legend up here. It shows you exactly what's happening. Let me zoom in. And first off, all these weird lines up here, that's not an accident. That is showing you the actual path of extrusion. So if you've ever worked with a hot glue gun, trying to squirt a whole layer out without just holding it down and pushing it out, you have to kind of make rows. That is showing you exactly what the rows look like at the thickness that the extruder is. If I orbit over, now I can see all the layers. That is showing me the there we go. That is showing me how a one-to-one how many layers and the thickness of those layers. That is my 0.2 millimeter quality piece. Let me pan over and you can see the sides more clearly. If I zoom in, you see that it's pretty smooth, but when you actually look at it flat on, you see there's those overhangs. That's what it's trying to show you, is that as the extruder pushes material out, it kind of squishes out a little bit. It doesn't come out from the nozzle, doesn't come out straight when it hits the print bed. What it does is it kind of squishes out a little bit. That's quite excessive. If anything, it more of squishes out just a bit wider than the nozzle was. So that's what it's trying to show you. It's not a perfectly smooth wall. There will be undulations, but overall it's pretty smooth. The other thing it will show you is if there's a more complex object, or for that matter, your infill, your hollowness. If you look to the kind of middle here, there's this slider. If I grab the top and drag it downward, you can see it going through the layers as it's printing. So when I get down to the rest of it, now you can see a projection of what that infill looks like. If I go down a couple more layers, there we go. That's what the thing looks like. That is the webbing. That is the webbing structure. By default, there are a variety of other options, and I will show you all those. But for right now, just want to show you that's what it looks like. That's one of the webbing structures. Add strength without having to make it overly solid. No need to make it solid. Slide that back to the top. Also down at the bottom, it will give you projections of how much material it uses, as well as how long. This basic thing at the infill and quality that I've chosen will take about 2.5 hours. They're not super fast, but that's pretty good. Set it to print, get it going. Go grab a bite to eat, mess around for a little while, take a nap, whatever. Come back and you got a thing. Or you got a rat nest because it failed, but we'll deal with that later. Okay, export. Export G code. Leave that on the desktop. Save. There we go. From there, those use SD cards. You have to use an actual SD card. Yeah. I've printed handy little tabs for them, so they're a little bit harder to lose. There are a couple of these, one at this unit, others at that unit. These are just different readers, USBs. So if your computer happens to have an SD reader, awesome. If not, grab one of these. You can plug it directly into your computer, or if you're using one of our desktops, use that. plug in, drag and drop it on, take it over to the printer, and I'll show you how to use those. The printer has to have this stay in. Other ones, you upload, it has an internal memory. Our Prusa ones do not have an internal memory. This is its internal memory, so you have to have this in. But we have a few of these going, so it's not like you can, or rather you can prep some and have them go. All right, so those are pretty much how to go about it. I will show you how to get the Prusa Slicer if you want, or you can do that on one of our computers if you don't want to bog down your own personal computer with more programs and such. But that's pretty much the rundown. I'll show you how to individually use these also, but I just want to tie up this video. So that's pretty much it. We have these we have these SD cards. This is the Slicer software. There are more universal ones like Cura. I like this one because I'm only using the Prusa, so why not use the dedicated software for it? And we'll go over loading those and such now. Okay, and I will be loading up where to get this. Basically, it's just the Prusa website under software. But I will attach all those to the video. Okey-doke.